Hi, my name is Paul Hopkins and I'm the leader of the science module in the primary PG, as well as doing some other things. You'll see me around doing bits and pieces this year. Well, I'm really sorry not to be here today to welcome you to the beginning of the course before the summer preparation and then the course starting in September. I'm actually in Vietnam at the moment doing some project work for the university. I'd like to say that this is what I'm doing, but unfortunately, mostly I'm doing this and working with teams. But I'd rather be with you than be out here. The main aims of the course, then, are to produce teachers, yourselves, who at the end of this year will be confident to teach science in early years, Key Stage 1 or Key Stage 2, but also feel competent to do so, so have the science understanding, knowledge and the skills. I hope also you'll find science teaching engaging, fun and exciting and pass that on to the children you'll be working with. Underlying the course is a philosophy that I call a three-hat ontology, or worldview. The first of these is that as you're undertaking the course, you'll think like a pupil. So you'll take part in activities, you'll understand and learn science, you'll get frustrated and confused, and hopefully then enlightened and excited about science, in the same way that the students you'll be teaching in your classrooms will. But you're not students, you're teachers in training. And so alongside of this, you'll be learning the pedagogic skills and the practical skills of being the teacher, how to plan, how to organise, how to resource, how to teach, and how to assess science in the primary classroom. At the heart of the primary PGCE is the idea of being a reflective practitioner. So thinking about your practice, thinking about what goes well and what doesn't go quite so well, and looking for ways to improve your practice. This will also be built into the science course. All of this is underpinned by academic research, those things that the research community understands about the teaching of science. So, in the course of the course, you will develop your core knowledge in science, understanding and skills. You will become better scientists as well as developing to be science teachers. But you will also develop those pedagogic skills in order to inspire your pupils in the classrooms you'll be working with in both your teaching practice and then when you go on to become teachers in September of 2018. Hopefully, you will also show enthusiasm and excitement and be willing to take the occasional risk in your learning. Science in primary classrooms should be engaging and fun. Hopefully you'll see many smiles like this as you're undertaking science in your classroom. It also is rooted in careful scientific process, in observation, in experimentation, in hypothesizing, in data gathering. Right from the earliest age, we expect children to exhibit these skills, and we coach and mentor them through that. It will develop their curiosity, their awe and their wonder at the world around them. And hopefully science won't just take place in the classroom, but outside in the school grounds or the local park or on field trips. Underpinning all of this are the questions that children ask and the questions hopefully that you ask too, and that stimulate their thinking, their curiosity, their awe, their wonder, and their desire to learn more. Questions like, why don't penguins' feet freeze? Penguins, after all, live on the ice, well, some of them anyway. So why are their feet able to cope with those extreme cold temperatures? And what about glue? Glue's designed to be sticky, so why doesn't glue stick to the inside of the tube? Then there are questions that are much bigger, literally as big as you can get. Where does the universe end? Does it end? If it does, what's outside it? And finally, we'll look at things all around us, perhaps in new ways. Why are different flowers different colours, have different numbers of petals? Can they feel pain? What's the purpose of a flower anyway? We'll explore all these questions and many more. In fact, one of the things I'll ask you to do is to look out for the kind of questions that children ask. So the content of the course really falls into three main areas. First of all is biology, exploring life and the organisms all around us. We'll look at plants, we'll look at animals, including humans. Remember, we're animals too. We'll look at evolution, food chains, classification, diversity, the whole range of biology. Then we move on to look at chemistry. What are things made out of? How do those things change when we apply forces to them, or heat, or input other kinds of energy? What happens when we mix or separate? What kind of bonds are chemical bonds or physical changes? How can we change, manipulate and organise the material world around us? And finally, we'll look at the physical world, at forces, at electricity, at magnetism, at light, at sound, and at the Earth and the universe itself. So those three areas incorporate the entirety of the science curriculum, right from the early years where things are organised into thematic ideas around knowledge of the world, right through Key Stage 1 to Key Stage 2. Of course, at the heart of this will be your learning. So you'll be keeping a learning journal throughout the course, helping you build up those scientific skills and knowledges that you'll need, but also pedagogic ideas and teaching ideas. But it won't all be lectures, in fact, far from that. Whilst there will be some lecture input during sessions, most of the sessions were built around you doing things. So you reflecting and thinking about the ideas that we're sharing. You undertaking practical activities, the investigations and the experiments that children will undertake. You doing learning activities in different pedagogic styles and different pedagogic ways, again, to mirror taking part in classrooms. One of my few absolute maxims is I would never ask pupils, students, grown up or little, to do anything that I wasn't willing to at least have a go at myself, be that singing, dancing, acting, jumping around, sitting in circles, sitting on the floor, reading stories, doing experiments, even holding bugs. So get ready for all that and much more during the time. And well, let's not ask what the student was doing here. We better move on, I think. The three ways that underpin the thinking of this course, apart from the three-hat ontology, are the ways that we will engage with pupils. So I would consider pupils in primary schools, first of all, not to be pretending at science or enacting science, but to be doing real scientists, and they are real scientists. Novices, of course, but they will grow and develop in their skills over the course of their years at the primary school. Secondly, the science they do must be investigatory. It's experimental. It's working on problems, investigations, trying to solve ideas, understand the questions about the universe that they have. It's not just theoretical looking in books, it's very much a hands-on activity. And lastly, we're not trying to just find out ideas to find out facts. We're making goals and making models of the world. So trying to understand the world in a way that it makes sense for the appropriate age group, and models that can be made more sophisticated as time goes on. So there'll be lots to do in the tiny number of months, the tiny number of sessions that we'll have September through December, where the bulk of the teaching takes place, and then as you go into practice. To help prepare, there are a couple of things I'd like to do over the summer. You can see here in the middle the white box, the subject knowledge audit test, and I'll tell you where to find the link in a minute. I'd like to try this just to see how your own knowledge is at the moment. Now, it's not a pass or fail test, it's very much a diagnostic test for you to look at and discover how you feel about your science knowledge, which you might be quite nervous of at the moment. But don't worry about that, that's my job to help improve that over the course of the next year. If you'd like to buy any textbooks, and it's not compulsory, but I would recommend it, there are two books you can see here by John Sharp, Graham Peacock et al. Called Primary Science Teaching Theory and Practice and Primary Science Knowledge Understanding. They're about £20 each. Academic books are not cheap, I'm afraid, and again you can find them on the link that I will point you towards in a minute. The course is supported by a very extensive website that will be available to you both during the course and into your first years of teaching, as well as when you're on practice. Lots of theory, but loads and loads of practical ideas and teaching ideas for you to undertake with the pupils. And you can find that at the web address you can see there, www.hullprimaryscience.org.uk. It is password protected, and you can see the username and password there. Please don't pass that on to people outside the course. If you log into that site and then go to Preparation for September 2017 link, you can find all the information, links to the books, links to the knowledge audit, and links to other parts of the website for use in the summer. However, it is the summer holiday, so I hope you're excited about September, but will also take some time over the summer to relax. Yes, there's a little bit of work to do, but on the whole, you're there to relax and prepare yourself for September. As I said, I'm sorry not to be here, but if you've got any questions, you can email me on the email address you can see there, or contact me through the contacts that you'll have been given during the rest of today. So, goodbye for now. I'm looking very much forward to seeing you in September when we start our sessions together. Bye then, and I'll raise a glass here in Vietnam. Thank you.